Well, I'm making a video for grade 9 ASP, end of term 2 focus questions. I actually made the video, solved everything, and did it all, and then I realized the audio wasn't recording. Amazing. So what I'm going to do is go back to the beginning, and I don't have the energy to write everything out again, so I'm going over everything in blue for this video. My apologies for that. In this first question, I'll go through the explanations again. What is the best definition of a vector? A vector is something that has size and direction, magnitude and direction. In this case, A is wrong because it says magnitude only, so I will not pick A. Direction only, that is wrong, I will not pick B. Both magnitude and direction is correct, so I will pick C in this case. D is wrong because it says no direction. Okay, what does the length of the vector represent? So if I had an arrow, that's 5 newtons, and I see the arrow and I wrote 10 newtons, you can kind of see the difference, right? It's the length of this vector, the magnitude of the vector. So the length is the magnitude of the vector. And the direction is whichever way it's facing. Okay, then we have to find the displacement of two vectors. So in this case here, we have the starting and we move up and then we move along that way. This makes a little triangle. From start to finish, final and initial, I will draw this and close the triangle. I have this side and this side. I need this side. We can use our trusty mathematician Pythagoras to help us with this. That formula is c squared equals a squared plus b squared. A and B, it could be either or, you're just adding them, doesn't make a difference. But then you have C, what we're trying to find. To cancel the square, I will take the square root of both sides. So let me just write that out again. The general formula should have been C squared equals A squared plus B squared. And taking the square root of both sides, I am left with this. Square root of 3 squared plus 5 squared. That gives me 58 kilometers. So the answer is not 58, it's actually 5.8. 5.8 kilometers. It's usually bigger than the other two sides. And in fact, if you look at these options here, they're all smaller than 5. So that's impossible. It must be bigger than 5. There is only one option bigger than 5, it is D. So in happenstance, this question, there is only one possible answer. But this is how you solve it. You use Pythagoras. Here is another example of using Pythagoras. The directions change, but they've given us the resultant. That's nice, they drew it for us. It'll be 10 squared plus 20 squared. 10 squared plus 20 squared. Take the square root, and you should hopefully get 22.4. So another Pythagoras example. Question number 8, we're having to find the magnitude and the direction. So the magnitude is the same as before. C is square root of a squared plus b squared, 15 squared plus 5 squared, 15.8. That is the magnitude done. That's the magnitude done. Next, we need the direction. The direction is the angle. The angle is right here in between the two. This is my angle, theta. I'm trying to figure out this angle. In order to do this, I need to use SOHCAHTOA. This is trigonometry, SOHCAHTOA. I have the opposite, I have my adjacent. By the way, the hypotenuse is the big line. Opposite is opposite of my angle. Adjacent is adjacent to my angle, which means next to my angle. So H is the biggest one, opposite is the easiest to find because opposite of my angle, the leftover is adjacent. I have O and I have A. I did solve for H, but maybe I made a mistake, so I don't want to use it. I will use my O, I'll use my A, so that means I have O and A. This is why I drew a box around tan. I'm going to use tan of the angle. Tan of the angle is O over A. If I want to remove the tan, because I want the angle only, it becomes tan inverse, tan minus 1. O over A. So to find my angle, I will do tan minus 1, opposite, which is 5, divided by adjacent, which is 15, 5 over 15. I will get 18.4 degrees to the horizontal. This is the horizontal here, and I am 18 degrees away from it. So that's the size and direction done. So that is tan. Now, in this case, we need to find the x and y components of the horizontal. I am given the horizontal. This is 40. I have it. I have an angle. I will use SOHCAHTOA. Let's label it. This is hypotenuse. This is the opposite. This must be adjacent. In this case, I'm trying to first, let's say the x component. That is my x component here. That's my adjacent, and that's my hypotenuse. A and H. Going over here, A and H is CAH. I will use cos. That's why I wrote it here. Cos theta A over H. I need A. I need this adjacent. I need to find this component. I will take my hypotenuse to the other side. By doing that, it will become H cos theta. 40 cos 30, 35. The answer will be B. That's the only option that has 35. So the answer is going to be B. But let's check the Y component just to be safe. The Y component is here. This is upwards. This is what? This is opposite. Opposite and hypotenuse. OH, OH. That is sine of the angle. Sine. I'll directly write H sine theta. This was H cos theta. This will be H sine theta. 40 sine 30, which is 20 in this case. We have our answer. In this one, it's the same idea, but they flipped it. I don't have the angle here anymore. I now have the angle up here. So from here, the opposite is on this side. That's the opposite. Hypotenuse is still there. That's the longest side. That's the right angle. This is the hypotenuse. The adjacent is now next to. So I flip these. And we can verify, because I wanted to find the horizontal. This is the x here. Horizontal is this arrow here. That is my opposite and my hypotenuse. OH sine. That will be V or H or whatever, sine theta. V sine theta. This is the vertical now, the y direction with this angle. That's my adjacent and my H hypotenuse. AH, ka. That's cos. That is ka. So that'll be cos of the angle. V cos theta. They used V. We can use H. You can use whatever you want, but they've used V. The answer is A. Amazing. Moving on to this one, we're trying to find the y component of a 95.3 Newton force at an angle to the horizontal. If I draw my horizontal, it is like this. My angle comes up something like this. And all I need to do now is find the y component, which is up here. The y component, that's my opposite. That's my opposite. This is my hypotenuse. OH sine. H sine theta or V sine theta or F sine theta. Doesn't matter. The value of H sine the angle. So I will write it. So the value of H is 95.3 multiplied by sine of the angle 57.1. I will put that in my calculator and I should get C. If I asked you for the x component, that will be the same idea. It will just end up being H cos theta. 95.3 cos of the angle. But I only needed the y component, so I did the y component only. Now, which factor does not affect friction? So friction is the rubbing force between two surfaces in contact with each other. So if I have something sitting on a surface, like a brick on a level surface, I will have friction if it tries to move. So there's a few factors involved. This is the formula. I call it FUF. F equals mu F. Friction, force of friction, equals mu. This is the coefficient of friction, the ratio between the two surfaces, two different materials, the relationship between the two materials. It will be different if you have like plastic with rubber, glass with concrete. If you put two surfaces together, there will be different frictions, different coefficient. So that is the ratio of the surfaces. This is the normal force. The normal force points up out of a surface, perpendicularly to the surface, and it is, in this case, equal to the weight. The weight is pointing down, and if it's balanced, then the normal force will be pointing up. W and F normal, weight, normal force, equal to each other. Okay, that helps us, because that means it depends on the mass, it depends on the weight, it depends on the surface itself. Let's see what it doesn't. So this says the weight of the object. That is correct. It does depend on the weight. The area, there is no area in my formula. So actually, the area does not affect the friction. If I had my bricks lined up like this, next to each other, there's two bricks for some reason. If I have the two bricks like this, that means, in this case, they will be exactly the same. It's the same W. It's the same two bricks over here. And it is the same normal force. The area didn't make a difference. It does affect pressure, but we're not talking about pressure right now. That's not something we need to worry about. It's just the friction we care about. The normal force, yes, I've just mentioned that. The roughness or smoothness, this is the mu between the two surfaces. So B is the answer. A brick slides along, which will increase the frictional force. Here is my brick sliding along. I want to increase. In order to increase the force, I must increase the weight somehow, W equals mg. I need to increase this weight. Putting a second brick on top, yes, that will increase the weight. If this was 10 kgs, or let's say 10 newtons, add a second brick, that's 2 of them. That is a total of 20 newtons. I have increased it. If I wanted to decrease the magnitude of friction, I must remove a brick, make the mass smaller, something like this, decreasing the mass. If I wanted to reduce, but the question asks me to increase. For that reason, I put the second brick on top. Very nice. Next, we move over to applying the formula into a calculation. We're trying to find the coefficient of friction. We will use our trusty formula, F equals mu, F. This now, I need mu. I will take this to the other side, and I will divide by Fn. So it becomes friction over normal. I will go ahead and solve it. I will see my friction. I've written it right here. Well, it's been written for me, I should say. 4 divided by 200. That arrow is because I was explaining something. I'll get to that in a second. 4 divided by 200 is 0.02. That was supposed to be a 2, by the way. 0.02. Now, if you were doing this in an exam and you see the two numbers and you accidentally flip them, that's why I did the arrow there, by the way. If I did 200 over 4, 200 over 4 is a big number. 200 divided by 4 is 50. Don't know why I use a calculator. Anyway, it is 50. That's too big. The number should be usually less than 1. These are all less than 1, by the way, so that means you know you've done something wrong. So it's less than 1. If you have a big number like 50, 10, 100, you've done something wrong. You flip the numbers around. That's a little tip there for you in your exams. Okay, next, we're moving on to this case over here. We're trying to find the coefficient of friction. That is F again. I will divide friction by the normal force. Now, in this case here, we're applying a 35 Newton force. It is a constant velocity. A constant velocity, that means the forces are balanced. My applied force happens to be the same as my friction force. So the force of friction will be 35. I don't have my normal yet. I haven't been given a normal, I was just given a mass. Like I said before, the mass can be W equals mg. 15 times 9.8, I will get 147. If this is 147, that means my normal force is 147. I have my normal force. 35 divided by 147 will be roughly 0.24, but noticed that here the person who wrote this question didn't correctly round the answer. This should be 0.24 because it's 0.238. Naughty, naughty. Anyway, the answer is B. All right, moving on. Let's look at the next one. Horizontal force required to keep this magnitude of, what's this called? Not magnitude, what am I saying? Not the weight, the mass. Why did that take me so long? Moving with a constant speed. It's because it's Ramadan. It's getting to me maybe. I don't know. Calculate the normal force. That is just finding the same thing we did here, W equals mg. It becomes the same as the normal force. So normal force is W, which is mg. So I just need to do 10 and multiply by 9.8. I will get the answer of 98 newtons. That's all you have to do. Formula, numbers, answer, by the way. If you want to get full marks, if you're doing a short answer, you must remember formula, numbers, answer. Find the coefficient of kinetic friction between the crate and the floor. That is F again, just like over here. We're going to find the coefficient is friction divided by normal. The friction force we have. The friction force is here. This is keeping it at a constant speed, so just like here, they are balanced. In this case, they were 35. Now it is 50. Friction is 50 divided by my normal, 98. I will get 0.51. That looks about correct. It's smaller than 1, so I am happy with this answer. Whatever number you get here, by the way, if you get it wrong, you will lose a mark here. But if you use that same number down here, you will not lose another mark. This will be given to you as full marks if you did that in an exam. That's very handy as well. You only get penalized once. Now, in this case, we're trying to find, I'll erase this and start over, maybe it's better doing that. Let's look at this. We have two forces. You can see that they are perpendicular to each other. We're going to find a resultant and an equilibriant. So if you do this, and I did a tip to tail method, you will see the first arrow coming down and the second arrow going across. Pythagoras again, the resultant goes in between the two. This is the direction of the resultant. If you use Pythagoras, 3 squared plus 4 squared, you will get 5. If you take the square root. This is actually a 3, 4, 5 triangle. If these two sides are 3 and 4, doesn't matter. 3, 4, the hypotenuse is always going to be 5. So that makes it easy for us. So directly we'll get the magnitude 5. They are balanced. The equilibrium balances. This is my resultant force going that way. My equilibrium is actually that way. It's 5 newtons that way. This is my equilibrium force. That's my resultant of 5 newtons. That's going to be important for the next question because it says the direction of the resultant. The direction of the resultant is going down this way. The direction of the resultant is going down. The equilibrium is the opposite. The equilibrium is trying to balance it, being equal. It's going to be in the opposite direction. Exactly opposite will be that way. So just check the arrows and they're opposite each other. Next we have a force moving a box up a rough slope. The force applied is up. The diagram shows 4 forces. We need to know friction and normal. Well, if the box is moving up, friction opposes the motion, so the friction must be down. Friction must be C. The normal is always perpendicular to the surface, so directly over here I have my normal. I have my friction, my normal, my applied force. I'm going directly downwards. This one would just be my weight. W equals mg. That will be my weight. So in this case now we have friction, which is C, and the normal, which is D. That is the answer over here. Very nice. Moving on to the next question. This is now the same idea. We have the free body diagram. We need to select the correct one. Let me just erase that and we can try this one again. Let's check. First thing we did, we know that this is sitting, resting on a plane, so it would be going downwards. The F slope will be this way. If it gets released, it will fall down the slope. It's not going up. So if that's the case, the friction will be up that way, opposing the motion. Normal stays the same, going up that way. That should be a straight line, by the way. And the weight is acting directly downwards. The weight, or sometimes written as Fg, force of gravity, that's also acceptable. F normal, this is correct. Friction is wrong. Friction should be the opposite. Over here, friction is wrong. That is definitely not right. Normal should have been up there, so that is wrong. And I have revealed the answer somehow. So in this case here, the normal is pointing up. Friction is in the opposite direction. Gravity is down. This is good. This is wrong because these two are wrong. Very nice. Over here, let's check this one. The free body diagram represents this, and we're now finding the component of the weight parallel. I've made a video on how to get mg sine theta. You can check it out in the lesson video. For now, we just need to know that this direction, down the slope, F slope, F of the slope, F slope is equal to mg sine theta. Perpendicular will be mg cos theta. So, mg sine theta, 227 times 9.8 times sine 30. I will get this answer here, roughly 1,110. That's parallel. Next, we're talking about perpendicular, as I already mentioned, mg cos theta. Same numbers, but cos theta, and I will get this answer. So I'm going to stop there, and I will make a fresh video and actually solve it this time, hopefully with my voice recording. Thank you.